Imagine stepping into a world bathed in a hazy orange glow, where the sky is perpetually veiled by a thick, smog-like atmosphere. This isn't a scene from a sci-fi movie, but a glimpse into the mysterious and enchanting color palette of Titan, Saturn's largest moon. But recently I got a theory, so watch till the end. Titan's unique coloration is primarily due to its dense atmosphere, rich in nitrogen and methane. When sunlight penetrates this thick, murky blanket, it sets off a fascinating chain of chemical reactions.
Wait, where are you going? No, please don't leave too early. I'll give you a Uranus, please stay.
High in the atmosphere, solar radiation breaks down methane molecules, which then recombine to form complex hydrocarbons like ethane and acetylene. These hydrocarbons eventually condense into tiny particles, known as tholins, which float down and scatter light. The result? A mesmerizing, rusty orange hue that envelopes the entire moon. Fun fact, the atmospheric pressure on Titan is even larger than Earth. And how about the surface? Stripping the atmosphere out, the landscape is a patchwork of subtle yellows and stark blacks, painting a picture of a world that's both alien and fascinating. The yellowish hues on Titan's surface are largely due to the accumulation of tholins, organic compounds formed high in the atmosphere and then raining down. These tholins give Titan its characteristic golden brown color, especially prominent in the smooth plains and dune fields, which stretch for hundreds of kilometers. Contrasting these lighter areas are the darker, almost black regions, which are often the result of hydrocarbon lakes and seas. This is what you have thought, right? But wrong. The black places near the equator are just deserts with sands rich in carbon. These bodies of liquid methane and ethane, found primarily near the poles, absorb most of the sunlight that reaches them, giving these regions their dark appearance. In some places, the contrast is so striking that it looks like Titan is painted with broad, sweeping strokes of yellow and black.
But you did paint this Titan?
That's pretty cool. But let's talk about the color of cats. You see, cats are some of the most diverse and fascinating creatures when it comes to fur colors and patterns. Dazzling array of coat colors and patterns that often make them look like they've stepped right out of a painter's palette. But where do all these wild colors come from? At the heart of a cat's colorful coat are two basic pigments, eumelanin and pheomelanin.
I'm sleeping.
Eumelanin is responsible for black and brown colors, while pheomelanin gives rise to reds, oranges, and yellows. The combination of these pigments and their distribution across the fur determines a cat's color and pattern. When it comes to producing black cats, eumelanin takes center stage. A high concentration of eumelanin results in a solid black cat that is basically even darker than trace 2b. Now don't get me wrong, the reflectivity of this exoplanet is just 1%, but don't forget it's a hot Jupiter and thousands of degrees hot, so it's going to be much brighter than you may expect. On the other end of the spectrum, pheomelanin is the artist behind the fiery coats of orange and red cats. These vibrant hues are especially common in male cats due to a fascinating quirk of genetics. You see, the gene responsible for red and orange colors is located on the X chromosome. Since males have only one X chromosome, it only takes one copy of this gene to produce an orange coat. This is why you see most of orange cats are males. Ever seen a cat with a sleek, bluish-gray coat? That's still eumelanin at work, but with a twist. In these cats, the pigment is diluted, giving the fur a soft, slate-gray appearance. This dilution effect can happen in any color, turning black to gray, red to cream, and so on. This cool effect is due to a genetic
dilution gene,
which essentially waters down the intensity of the base colors. White cats, on the other hand, get their stunning coats from a lack of pigment altogether. This can happen in a few different ways. Sometimes, a gene causes the cat's coat to lack color entirely, resulting in a pure white furball. Other times, the white color comes from the presence of a white
spotting gene,
which can create anything from a tiny patch of white to a completely white cat.
Tuxedo.
Now, let's talk about the showstoppers, calicos and tortoiseshells. These multicolored cats are like walking rainbows, featuring a mix of black, orange, and white patches. The unique patterns of calico and tortoiseshell cats are due to a phenomenon called X inactivation, where one of the two X chromosomes in each cell randomly shuts off. This creates a patchwork of colors depending on which X chromosome is active in different parts of the body. So, most calico and tortoiseshell cats are female because they have two X chromosomes, allowing them this color variety. Beyond genetics, a cat's environment can also play a role in its coat color. For instance, some Siamese cats have a temperature-sensitive gene that causes their fur to darken at cooler temperatures, resulting in darker ears, paws, and tails. This is why Siamese kittens, which are born white, gradually develop their distinctive color points as they grow. And guess what is the most common color of cats? According to a study from Oklahoma State University, the most common color pattern is tuxedo, followed by orange and calico. But if you make a rough average of the RGBs or place these three color patterns together, in both cases you get approximately a color palette of Titan. I mean really, now take a look at the surface of Titan. Cats are from Titan, QED. Alright, enough joking. But let's talk about the topic of life on Titan. Titan is one of the most likely objects in the solar system to secretly hold life. But the question is, why? Unlike other moons that are basically chunks of extremely boring rocks, at least you can still find something interesting on Titan. Titan's thick atmosphere is rich in nitrogen and methane, which undergo complex chemical reactions under the influence of solar radiation and cosmic rays. These reactions produce a variety of organic compounds, just like a bunch of stars can generate a complex structured galaxy.
Well, you need a billion bunch.
These organic molecules are crucial for prebiotic chemistry, which is a precursor to the development of life as we know. Also, Titan is unique among moons in the solar system for having stable bodies of liquid on its surface, but instead of water,
as we mentioned before,
these are lakes and seas of methane and ethane. These liquids can serve as solvents, analogous to water on Earth, providing a medium in which chemical reactions can occur. While methane and ethane are not as versatile as water for supporting life, they could still potentially support some form of life.
And finally,
just like Jupiter's Europa, beneath Titan's icy crust, there is strong evidence suggesting the existence of a subsurface ocean composed of water mixed with ammonia. This ocean could potentially be a habitat for life, similar to what scientists speculate for Jupiter's moon Europa. Ammonia acts as an antifreeze, lowering the freezing point of water and thus maintaining liquid conditions at very low temperatures. If this ocean interacts with the rocky core of Titan, it could provide necessary minerals and chemicals for life to exist. By the way, do you know that there are approximately 650 million cats on the planet Earth? If they form a spherical celestial body themselves, this object would be 85 m in diameter, which is a bit larger than the average asteroid size in the so-called asteroid belt, and also bigger than some moonlets in Saturn's rings. However, given the fact that Saturn as well as its moons are a little bit cold for you, do not visit there. This is Cat and see you next. But perhaps the Sun is not the best star for life. This video says Alpha Centauri b might be